Is atmospheric momentum the key to our immediate future? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 7th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Clay Goose, B. Nadine, Tim Caston, Evolution Moto, and Coach Nate. These are all longtime contributors. We really appreciate your support for the channel. And now, with that, let's get to work. We'll start by looking at significant wave heights around the planet. Starting in North Pacific, there is actually some activity. A gale pushed off Japan, produced 20-some foot seas. We'll take a look. That was yesterday. Those seas are fading, but this system is forecast to reorganize over here in the northwestern Gulf in the coming days, producing maybe some seas in the 20-foot plus range, targeting the U.S. West Coast, maybe making for some early season swell. We also see Hurricane Kiko approaching the Hawaiian Islands. Current track forecast to move north of the islands, providing some degree of easterly and northeasterly swell for exposed east-facing shores of the Hawaiian Islands. For the southern hemi, a gale of some sort is trying to organize right here off of New Zealand. Seas of not any interest at the moment, but as we get into the coming week, things should pick up a little bit. So another southern hemi swell is forecast developing, and there is one on the way currently hitting Hawaii as we speak. North Atlantic, the same pattern of activity forming off the, I'll call it the Canadian Maritimes, building and then pushing into Europe. There is a significant swell that certainly hit from Hurricane Erin, and the pattern, though not nearly as productive as Erin, is still looking pretty good for the coming weeks. South Atlantic, not a whole lot going on. A little gale down here with 22-foot seas, but weaker pattern, and that looks to continue. The Indian Ocean, doing a little bit better, though. Gale here with 26-foot seas in the middle South Indian Ocean, generating swell and other activities south of New Zealand in about the 18 to 20-foot range, producing also swell there. So, all in all, the transition from a summer pattern to a more, I'll call it fall pattern, appears to be shaping up. But before we get into all that, let's take a look at current conditions. We're going to start off the Pacific Northwest. There, the Grays Harbor buoy, number 036 here. It's on the border between Oregon and Washington. We're looking at all the energy that's hitting that buoy, all the way up from 33.3 second period. That's very powerful long swell energy, which there is 0.0 feet of it occurring, all the way down to pretty much wind chop, 5 second period swell, and what is that, about 0.3 of a foot. Not a whole lot going on, just a spread of generic half a foot energy split between about 15 seconds the whole way down to 7 seconds. See what the algorithm says here. Primary swell 1.9 feet at 10.3 seconds from 272 degrees, making surf at about 2 feet. And then secondary swell 1 foot. This is your southern hemi swell. Background swell 1 feet at 14.3 seconds from 220 degrees, making surf at about 1.5 feet. I checked this morning, surf up there, you know, maybe thigh to waist high, something like that. Pretty quiet for the moment, but it seems that a building pattern is going to be setting up with luck. Going down to Northern California, we're using the Point Sur buoy off of Monterey there, buoy 157. But of note, buoy 029, the Point Reyes buoy, the buoy has been replaced or at least repositioned. There is data coming out of it. It's not something that I can get to quite yet. I think they're doing calibration tests on the buoy, but the buoy is there. It looks like it's going to be good just in time for the start of the fall season, so that's great news. But for right now, Point Sur buoy will work quite well, especially for southern hemi swell for Northern California. And as you can see here, there is not a big amount, but this steady amount of energy split between about 16 seconds and 11 seconds in about the 1 foot range, and not a whole lot of wind swell. That lack of wind swell, by the way, means there's not been much northwest winds, which means the ocean temperatures or the upwelling pattern that it was so strong earlier this year is at least for the fall season settling down. Water temperatures are up significantly and quite warm. All right, primary swell 1.8 feet, 14.8 seconds from 188 degrees, making surf at 2.5 or 2.6 feet. Within that secondary swell 1.8 at 11.6 seconds from 249 degrees, putting surf at about 2 feet. Yeah, there were some chest high sets this morning at select breaks. Down to Southern California, the Point Loma South buoy, number 191 off of San Diego. Same sort of profile, a little bit more energy here in the 14.3 second period range, but everything really looking like Southern Hemi swell. Primary swell 2 feet, 14.7 seconds from 179 degrees. Yeah, it's a real south angle. Not a whole lot of this getting into more protected breaks in Northern California, but Southern California doing quite well. Surf 2.9 feet from that, and then secondary swell 1.4 feet at 11.3 seconds from 203 degrees, adding another 1.5 foot of energy in the background. There were sets in the, I think, head-high range at top spots in Southern California this morning. And then over to Hawaii, the Lanai buoy, number 239, and this is a bit of a shocker here. There is way more swell than the models forecast that anyone would have guessed. You can see a pretty good spike here at 2.8 feet in just one period band in the 15.4 second range. So primary swell 3.6 at 15 seconds from 187 degrees, making surf at 5.4 feet with secondary swell 1.2 feet at 11 seconds or 11.6 seconds from 195 degrees, adding another 1.4 feet there. There are sets building on the south shore of Oahu, several feet overhead. So clearly there is swell hitting. The question is, will that translate to California? The big question, the short answer is I don't really know. But for now, Hawaii is getting much more surf than was expected. So we'll do a little rewind now. We're going back over the past week. We're looking at significant wave heights for the North Pacific Ocean. We're back to Sunday, the 31st of August. That was last week's video. Just roll through, look for any activity. Remnants of a little gale here that faded out. That did produce swell for Hawaii. Here's Kiko off well east-southeast of the Hawaiian Islands. Put this into motion. This little system here actually produced some swell. That was on, we'll say Wednesday. That is actually hitting the north shore of Oahu. I mean, there was some, waist to chest high sets it looked like from as best I could tell. Seas pushing to about 18 feet. Now, most of this was aimed well east of the Hawaiian Islands and too far away from California to make any difference. But again, little swell was hitting the Hawaiian Islands this morning. Another system developed over the dateline on Thursday, Friday, and then another system. This was really of tropical origins, but then turning extratropical on Friday. And you see right here, it was at about 22-foot seas. These are the highest seas over this entire domain, but that's from Kiko, 34.8-foot seas estimated out here. But I'm guessing that was about 22 feet. And there you go. That looks like more like 26 feet, maybe 27 feet. That was yesterday on Saturday. Oops, barely pushing to 30 feet. So swell from that could reach the Hawaiian Islands a couple days out now. And then let's see, where are we at? We're at Saturday. We can go to Sunday. The system started fading. We're at current time right now. The projected path of this is going to be of interest. We'll get into that in a moment. Looking back the past week over the southern hemi in the Pacific Ocean, Sunday, the 31st of August. Now, here is the gale that produced the swell that's currently hitting Hawaii and is forecast to push into California 2 days from now, something like that. Seas were 31.6 feet, and there was a good amount of south fetch in this, probably targeting Hawaii better than California. Again, Monday, we had 32-foot seas, 31.7, 32 foot, and then faded out Tuesday sometime, and then dropped off from there. Swell from that, of course, is in the water, hitting Hawaii bound for the U.S. West Coast. After that, we're looking for anything that looks like it's 28 feet or even 26 feet or better. Not really seeing it. Now, there was this gale that developed here right south of the southern tip of New Zealand, but that was all shadowed relative to Hawaii and for the U.S. West Coast for the most part. And this system pretty much impacted land. We'll get this up to current speed. Here we are Sunday, and not a whole lot going on. So this one that developed off of New Zealand is the primary swell producer for the moment. Off to the North Atlantic, again, 18-foot seas over a broad area. Is that 18? Yeah, 19.3. Oh, that's right back here. Yeah, so 18-foot seas. Currently, this was a week ago, impacting the British Isles and France and that area. That's all long gone now. Another system tried to organize but faded out. Then redeveloped as it pushed into the Bay. I think it's the Bay of Biscay, targeting France. See what else came behind that. We're into Thursday, Friday. You can just do, here you go again, this consistent pattern of energy tracking, probably being fed by the Jetstream, pushing from Canada over Europe or into Saturday, and there we go, Saturday. So even this morning, early this morning, 18.8-foot seas off of Ireland, pushing into the coast, and there we are, current time. So more swell bound for UK, Ireland, Portugal, maybe France, and maybe even down to Morocco. Then to the South Atlantic. A week ago, little bits of 18 to 20-foot seas, nothing too significant, 22 or 3-foot seas. This was on Monday, building, but most of the building wasn't happening until it was east of South Africa, so no real swell from that. Now, here was a better system that developed on Tuesday with, we'll actually take it back a frame. Right there was that 33-foot seas. Most of the energy aimed off to the east, but because it's so close to South Africa, some sideband energy, I'm sure, radiated up into that direction. You can almost see little bits of the swell front targeting the southern tip of South Africa. We're into Thursday now, Friday, same sort of pattern, nothing big, no 35-foot or even 30-foot seas really, just more in the low 20-foot range seas. And we're into Sunday. Not a whole lot, so more or less a quiet pattern for the time of year for South Africa. And then finally over to the Indian Ocean. We'll put this in motion. Again, the same sort of 20 to 24-foot seas, nothing significant. There we go, one solid gale, 37-foot seas. This was on Tuesday night, the 2nd of September, pushing more south than east. On Wednesday, 38-foot seas. I mean, still, you can see a swell front here, likely heading for Indonesia and southwestern Australia. That system faded out. It's like it hit a brick wall right there and proceeded no further to the east. But you can see the swell front there. This was on Saturday. Take this on to Sunday. Just now, swell likely starting to hit that area, and then other energy trying to build back behind, but seas 25 feet or 26 feet, so nothing super significant. All right, let's move to the future. We're going to do a deep dive here for the South Pacific. We are looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push into the jet to the north. Here's the northern branch of the jet stream. Here's the southern branch, and you see right here the southern branch actually is pushing up and trying to merge with the northern branch, getting consolidated. Here's a northward push right there. That is a trough, and that's what we want. That helps support the formation of gales. When you get a trough, the jet pushing to the north like that, you get a clockwise flow aloft, and that can manifest itself down at the ocean surface. That is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface and produce seas, generate seas. The seas, as they radiate away from the fetch area, the lesser period elements of those seas fade off because they're weaker energy, exposing the longer period swell. When swell hits your beach, that produces surf, and preferably swell with a period greater than 13 seconds. All right, so as we get into Sunday, you can see a trough trying to develop right here. In fact, you literally see a clockwise circulation right there. That is exactly what we want to see. The trough actually gets steeper as we get into Monday while sweeping east. And there is a fully legitimate trough forecast for the South East Pacific, The cutoff for California is about 117 west, so right about there. That's where San Diego is. So potential for California swell, and of course South America, Central America, Mexico, all that. If this develops, and notice actually winds rebuild up into the, did we get 3? No, just 2. 150 knots pushing to the north. So that's pretty good for the southern hemi. Good support for swell development. And then that whatever happens moves east of the Southern California swell window on Wednesday, still targeting South America. And you see it just persists on for a pretty good long time. The problem is behind that, a whole lot of nothing. The southern branch, very weak, falling south over Antarctica proper, does nothing to support gale development. But then we get into Saturday, a weak trough. Here, the same sort of scenario. Northern branch, southern branch. They try to join over New Zealand on Saturday. Now notice, this is not very strong. So we'll see. The models are picking up on something developing here, but it might be a bit overstated just by looking at Jetstream level winds. So let's go down to the surface. Surface level pressure and surface level winds. It takes winds blowing on the ocean surface, imparting energy to this ocean to generate seas and therefore swell. There is this, we know there's a trough right here. There is a gale with 45 knot winds, very tiny. And almost looking at the vectors here, most of this looks to be falling almost southeast more than east. But then we get into Sunday night, 50 knot winds build, aimed more off to the northeast, and going to 55 knots into Monday, pushing off to the east, while additional fetch builds behind that at 35 to 40 to 45 knots over a building area of coverage and lifting off to the northeast. So as we get into Tuesday, and again, cutoff for Southern California right around there, we have a pretty good sized fetch here, offering potential. It all moves east of the Southern California swell windows we get into Tuesday night, early Wednesday, but still targeting all of South America, Peru, up into Central America and Mexico. And that continues into Thursday, and then Friday. Finally, as we get into Friday, that starts fading out. But then notice here, that other little trough, winds forecast building to 55 knots, at least 50 knots, we'll say, just south of the southern tip of New Zealand. This is on Friday, percolating in that area with a broader secondary fetch starting to build, lifting off to the northeast. We're into, there we go, 180 hours out. Potential for swell development in this area, but still, it's a long ways to go, so we'll have to see. You know, this is far from a foregone conclusion. The Southeast Pacific gale a couple days from now seems more likely as something I'd put money on. All right, so let's go see what effect those winds have on the ocean surface. We're looking at significant wave heights. Here's our little tiny gale pushing off to the east, 28-foot seas as of midday Sunday, building to 37 feet late Sunday night, but all pushing off due to the east, 41-foot seas Monday morning, continuing, what do we got, 39-foot seas. But here's the secondary fetch that's building. I think this is going to be more successful at generating swell pushing to the north because it's aimed more off to the north than off to the east. We are here at Tuesday, the 9th of September, with 33-foot seas aimed off to the northeast and in the southern and northern California swell window. That holds into about midday Tuesday, and the whole thing starts moving east of the California swell window. Still producing 28-foot seas, targeting South America, Central America, and all the targets there. So a late season, perhaps halfway decent pulse of swell. I would say, well, let's put this back. This was on, what day was that? Tuesday, so up into California about a week from now, so, or a week from the 9th of September, so what's that, like the 16th or so, maybe the 17th of September sort of thing. And we'll just continue on out, see if there is any other hope. We know there's a little thing that's supposed to be developing here, a little hint of it, but I think, whoops, oh, there we go. I see a little drop out in the model. 180 hours out, 32-foot seas aimed to the northeast, embedded in a broader area of 26 to 28-foot seas. So maybe some more hope longer term. Let's go take a look now at the North Pacific. Hurricane Kiko right here, Hawaiian Islands right there. Here is the remnants of the system that developed off Japan yesterday on Saturday. Two things to be looking at here. We'll first take a look at Kiko, and we're not diving in very deep because the current models suggest this system down to, I think it was on Tuesday morning, like right there, strong tropical storm force, like 60-knot winds, but north of all the Hawaiian Islands, swell from it radiating out, actually hitting the Big Island, east shores of the Big Island on Monday, and then building in up to Oahu on Tuesday. Nothing huge. Of course, maybe the models are understating. This is not a broad system, and then it moves off. Let's go back now and check out the other system. This was the storm or the gale on Saturday was off Japan, reorganizing here over the North Dateline region on Monday, building into the northwestern Gulf on Monday night with seas to 31.5 feet, aim off to the east, and that then fades as we get into Tuesday, but pushing well off to the east. You would guess swell from this little sideband energy is forecast reaching down into Hawaii because, well, we'll just do a quick look here. There's the peak seas, there's Hawaii, there's the cutoff right there. Now, most of the energy aimed off to these, so it's only going to be very indirect energy pushing, like 70 degrees off to the south. Most of the brunt of the swell will probably be in this area, we'll say from Oregon on northward. But there is forecast to be some swell energy reaching down into California. But up in here, you're at like 305 to 308 degrees. So relative to San Francisco Bay Area, that's going to be shadowed by the Farallon Islands. Nothing huge, but a early season taste of North Pacific swell. Actually, and so the good news here is it's actually kind of right on time. You know, not super early, not super late, not super big, but it's early September, and to get any energy out of the Northern Gulf, that's not a bad deal at all. And then, if you really believe the models, another system is forecast forming here off of Cape Mendocino on Saturday with seas to 21.4 feet. Does it get any bigger than that? No, that's about it. Another system up here in the Gulf as well. I mean, you just look at this and you go, wow, that's pretty impressive amount of activity, nothing huge swell-wise. And if you look at the GFS model going out 2 weeks, there's a whole string of systems following the same track. The exact same track as what's happened in the North Atlantic, suggesting the Jetstream is doing okay here. So, things to look forward to in the North Pacific as well. To the North Atlantic, the forecast, well, there we go. Continued 20-foot seas off of Ireland and England into Monday. That fades out. Here comes yet more activity, suggesting the Jetstream is strong in this area. 16-foot seas, 17.6, sorry. More, I'll call that wind swell. There's a little area of 19-foot seas on Friday. Let's see where, and here comes yet another one, a rather prolific pattern, nothing super strong, 24-foot seas, building to 31 feet on late Sunday, the 14th of September. So, again, continued suggestions that the North Pacific jet is doing pretty well. This is part of what we were talking about in the title of the video. We'll try to pull all these pieces together as we get into the MJO forecast and the ENSO forecast in the second half of this discussion. To the South Atlantic, we'll just see if there's anything, 20-foot seas, 28-foot seas, but almost falling southeast. That's probably not good. Oh, building to 39 feet due south of South Africa. I don't know if any swell's really going to make it up here. It's probably going to push more into the open Indian Ocean. Another little gale with 31 or 32-foot seas. Trying to hang on, but not really. I mean, it generally looks like South Africa is out of the loop for the coming week, and maybe this is part of a trend for the southern hemis starting to fade, at least in this area. And then the South Indian Ocean, well, just the Indian Ocean in general. All right, we'll see how this all plays out. Not a whole lot looking. We're into Tuesday. Now, here's that gale. Let's see what it does. Nope, falls apart, doesn't even make it maybe a third of the way across the South Indian Ocean. We're into Thursday, Friday. There we go. Now, there's a solid system forecast, 41-foot seas. Another one over here with 41-foot seas. all that energy aims south, but that looks like it has potential for the usual targets of Indonesia, Bali, the Mentawai Islands, and down into Western Australia. That fades out. Do we get anything more behind that? Yes, we do. So, Indian Ocean, it really seems like the focus of activity is here and then over to, I'll call it the Southwest Pacific, but then we do have that one gale forecast in the Southeast Pacific too. So focus Indian Ocean and Pacific, not so much the Atlantic. Local wind forecast for California and Hawaii. California here, this would be Southern California. There's the Mexico or the Baja border. Point Conception behind the tag there. Monterey Bay right there. San Francisco Bay up into Cape Mendocino and then the Oregon-California border. Hawaii right here. Kiko, plain as day. You can see it. We put all this into motion. That was on Sunday. On Monday, you see very light trades. It's when you get this shade of blue, light blue, baby blue, whatever you want to call it, that is 15-knot winds. So we're talking 5-knot, 10-knot winds. So Monday looks like a repeat of Sunday. Kiko approaching the Hawaiian Islands, pushing northeast of it. You see it here. 15-knot winds, not even reaching the Hawaiian Islands as we get into Tuesday morning. All the fetch over on the northeast side of the storm, really aimed more up in this direction. So when the storm was down here, that's when most of the swell will be generated. So Tuesday, light wind regime for California. Trades, 10, 15 knots for the Hawaiian Islands. Wednesday, pretty much the same deal. Winds build to 15 knots over Cape Mendocino. Kiko, probably doing something here. There we go, 15-knot winds building trades from the east behind Kiko, but nothing like particularly worrisome at all. Northwest winds, 10 to 15 knots for California on Thursday, the 11th of September. Trades in the 15-knot range for the Hawaiian Islands. Friday, pretty much the same thing. Here's the local gale forecast forming off of California. Kiko, long gone, trades 10, maybe 15 knots for the Hawaiian Islands. Saturday, 40-knot winds, theoretically, targeting the U.S. West Coast. Hard to believe this early in the season. Another system off the eastern Aleutians there. Trades pretty light for both California and the Hawaiian Islands. Get into Sunday, we're about a week out. You see the low fading, poised to start moving into Cape Mendocino region, but a light wind regime for California. Trades 15 knots for the Hawaiian Islands. And there we are then into the model run. Another low over a pretty broad area, only producing 20, 25-knot winds in the Gulf of Alaska. So a pretty good early season pattern shaping up. The backpackers temperature forecast for the Yosemite, upper regions of Yosemite, the High Sierra, the intersection of the Pacific Crest Trail and Tioga Pass Road there at Tuolumne Meadows. That's at 8,700 feet right there. Today, temperatures in the 45 to, say, 50-degree range. But as we get into Tuesday, you see temperatures falling to 40 degrees, maybe 45 degrees. Here's the freeze level here, moving from 12,700 feet down to 10,500 feet. That is a good dip of cool air, and that holds into about Friday. So the whole of this work week getting cooler for the Sierra, and things warm up a little bit, but temperatures still only in like the 45 to 50 degree range from, I'll say, Friday morning, the 12th of September, on through the end of the model run. This would be Wednesday, the 17th of September. And freeze levels back up at about 12,500 feet. The surf forecast, spot forecast for the Columbia River area there, the intersection of the Oregon and Washington border. Not a whole lot going on, but then if that gale develops off the or south of the eastern Aleutians, you see swell arriving on Thursday into Friday and Saturday. Nothing huge, 5-foot sort of range, then slowly trickling down through the weekend into the early part of the following week. And winds all the while pretty weak, even actually offshore in the early mornings of Friday and Saturday. So let's see, check swell heights. 4 feet at 13 seconds, 4 feet at 12 seconds. Definitely looks like some surf and some southern hemi swell. I mean, I guess that is, no, that's easterly swell from other sources. 1.5 feet at 12 seconds sort of thing. But So, looks like swell is headed into the Pacific Northwest, and if it's headed there, probably heading down to San Francisco as well. And here we go, Ocean Beach, California, or San Francisco, surf heights in the 2-foot range sort of thing until you see the arrival of northwest swell, with surf heights building to about 4.5 feet, something like that, and that would be building on Friday, peaking on Saturday, continuing into Sunday. Northwest wind, a bit of an issue, but where this is anchored is a bit off the coast, so wind's probably a little bit less near shore. Let's go look at swell heights here. 3.5 feet at 12 seconds, 3.5, maybe 4 feet at 11 seconds. So nothing huge, rideable, and this is shadowed in the SF Bay area, so the surf heights you see here, yeah, you might get them since this isn't a particularly long period swell, but it could be something less. Don't expect a whole lot, but it would be a taste of fall at north-facing breaks. Down to Southern California, surf heights, 2 feet, 1 feet, not a whole lot going on, 2.2 feet as we get almost a week out. No wind. Let's take a look at swell heights. Bits of southern hemi swell, 1.2 feet at 13 seconds, 1.4 feet at 14 seconds, somewhere in here. This is where the model is kind of falling apart. You see it's not showing really any of that southern hemi swell that's hitting Hawaii, 1.6 feet at 14 seconds. I'm not sure I believe this. It's entirely possible that we could see a bit more energy than what is shown here, and that would start sometime on Tuesday and continue into Wednesday and Thursday. But then we see additional energy, 1.5 feet at 15 seconds, building into Saturday and Sunday, a week out. All right, so this is a good test. The South Shore of Oahu, surf heights on Sunday, showing 3 feet and then slowly dribbling down from there. But we know that surf heights are probably 4 to 5 foot Hawaiian and on the bigger sets. I saw it myself. There are real waves. Let's see what the model actually says. 2 feet at 14 seconds. And what do we see? 3.5 feet at 15 seconds on the buoy. In fact, here we go, the Lanai buoy. The reading at 23Z, so that's, what is that? That's 4 o'clock California time, so what is that, like 1 or 2 o'clock Hawaiian time? 3.6 feet at 15 seconds from 187 degrees. 3.6 feet at 15 seconds. The wave model for Sunday says 2.1 feet at 14 seconds. So the model definitely blew it, and that one reading is not, that we saw in the buoy. That's not some anomaly. There's multiple readings in that range. So the model grossly undercalling what is happening. Jefferies Bay, South Africa, surf heights 15 feet supposedly as of today, trickling down into the 7-foot range, 7 to 8 foot range as we get into midweek, and then coming up as we get into the weekend, 11 feet up to 14 feet. Now that's a bit overstated for sure. Swell heights 10 feet at 14 seconds down to 5.5 feet sort of thing at 12 to 13 seconds. A little bit more energy on Saturdays, 7.5 feet at 14 seconds, and up to 9 feet at 15 seconds. So bit of sideband energy working its way into Jefferies Bay over the coming week. And then finally Bali, the catcher's mitt for all swell energy in the South Indian Ocean. Surf heights 10 feet, 12 feet, trickling down into the 6-foot range, 7-foot range. I mean, that's probably more seasonally appropriate, but late season surf for sure. Swell heights, 8 feet at 14 seconds, 7 feet at 16 seconds. That would be very nice. I would like that. 4 feet at 13 seconds, then 4.7 at 15 seconds. So a good long run of surf continues for Indonesia and likely southwest Australia. Let's go to take a look long-term now. The long-term outlook, and we're going to focus on the two major weather oscillations that affect the potential for swell in the mid-term and long-term. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We're going to start by looking at the MJO, the Madden-Julian Oscillation. There are two phases, the active and the inactive phase. The active phase is like a low-pressure system, the inactive phase like a high-pressure system. They rotate orbiting or rotating around the planet going west-east. The active phase on one side of the planet, the inactive phase on the other. They rotate around the planet like that. The active phase is our friend when it moves over the Pacific because it's a low-pressure system. It dampens trade winds. Trade winds are generated by high pressure. When low pressure interacts with it, it shuts down the trades or dampens them or even reduces them. And that, in turn, because low pressure creates rising air, takes warm, moist air at the ocean surface, lifts it aloft. That gets fed into the jet stream, making the jet stream stronger. And a stronger jet stream is more consolidated and also helps dig out troughs, which then, of course, help produce storms. The inactive phase of the MJO is a high-pressure system. It marries up with existing high pressure that's always in the Pacific, feeding trades, making them stronger. That is downward falling air. Downward falling air cuts off the flow of moisture into the upper levels of the atmosphere, makes the jet stream weaker, causes it to split, and be less effective at producing storms. All right, so we go and we examine the trade wind speeds across the Atlantic. The Pacific. We're looking at data from the TAO buoy array, a series of buoys strung from the East Pacific to the West Pacific. There's the equator right there. That is New Guinea there. The international date line is right there. We're just looking at the arrows. These are 5-day average winds. They look pretty strong from the east over the East Pacific, pretty strong over the West Pacific, and quite solid indeed over the West Pacific. But it is not the actual wind speeds because they tend to blow stronger sometimes of the year, less strong others. So we look at the anomalies, the difference in wind speed for this time of the year. In the East Pacific, winds are, we see a little bit of one arrow here that's a westerly anomaly, a couple little easterly anomalies. Trade's pretty much normal here in the East Pacific. Trade's dead normal over the Central Pacific, but over the West Pacific, they're pretty much nuking out of the east, stronger than normal. So this looks like the inactive phase of the MJO here, and then maybe just no MJO at all, or a weak active over the East and Central Pacific. Let's go look at the forecast. Here is zonal wind anomalies, just fancy words for are the trades stronger or weaker than normal. Blues, stronger than normal trades. Yellows and reds, weaker than normal trades, if not westerly anomalies. But this is the whole planet on one chart. So let's see if we can get this centered right about, there we go. That's the international date line right there. This is the whole planet. California is about at 120 west, and the far west Pacific, and this is where things really matter, starts at 125 east. Now, what we want is westerly anomalies in the West Pacific, like what we had right here. This is back in late August. That would be the active phase of the MJO. This is weaker than normal trades pushing into the West Pacific. But you see, since then, trades have built. They've been pretty strong, like even as of today. But then we see, well, they're still providing a lot of coverage, filling just about the entire equatorial Pacific until about September 19th. Theoretically, maybe a little finger of westerly anomalies pushing halfway into the Kelvin wave generation area. Maybe this is a sign of the active phase of the MJO, but all in all, this looks like pretty much inactive phase forecast for the next 5, 10, 15 days. Let's go look at some other data. Outgoing long wave radiation. That's just fancy words for cloud covers. If you have more clouds, there you don't get sunlight bouncing off the ocean surface. The clouds prevent the reflection of sunlight off the ocean surface. Why would that be? Well, if you have the active phase of the MJO in control somewhere over the planet, because it's taking warm, moist air and lifting it aloft, warm, moist air condenses into clouds, and that is a good sign of the active phase of the MJO. So blues here represent less outgoing long wave radiation, which basically means more clouds. So let's get ourselves oriented. South America, Central America, New Guinea, the equator right there, the date line right there. The all-important area is here in the West Pacific because the jet stream flows from west to east, be it either in the southern hemi or the northern hemi. But when the jet stream hits rising air and that warm, moist air, it would get energized as it makes its way across the Pacific and be good for supporting storm development. When you have these oranges and yellows, that means less clouds than normal, more sunlight reflectivity. So that would be inactive phase of the MJO today. This is a statistic model, but it shows 10 days from now, about a week and a half from now, active phase of the MJO building in the West Pacific, getting fairly strong 2 weeks from now. That would be a great outcome. Unfortunately, the GFS model, the dynamic model, says inactive, 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 and at best just dead neutral 2 weeks from now. So look at the last frame here. That's the statistic model. That's the dynamic model. I tend to favor the dynamic model. I think this is a gross overreach by the statistic model. So probably more of a continuation of the pattern that we're in for right now. All that said, if we are in the inactive phase, North Pacific's coming in line, Southern Hemi's doing things. So maybe the MJO isn't having a whole lot of influence. And that is always a real possibility. Right, phase diagrams for the same two models. Statistic model here, dynamic model here. Well, how do you read this? Well, the MJO moves from west to east along the equator, from the Indian Ocean to the Maritime Continent, over the West Pacific to the East Pacific, under the United States. Remember, it's on the equator. Over the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now, so right square in the Indian Ocean. And the further the dot is away from the circle of death here, the stronger the MJO is. So a weak active phase of the MJO in the Indian Ocean today, 1, 2, 3 different versions of the statistic model. The CA run of the model suggests, and here's where you get that strong active phase. Literally, it says a strong active phase moving into the West Pacific 2 weeks from now. That's the statistic model. The dynamic model has the active phase just noodling around here in the Indian Ocean, inside mostly the circle of death, suggesting a very, very weak active or a very weak MJO signal, not really doing anything, which has kind of been the case for a couple months now. So then here's the CFS model going out 1, 2, 3, 4 weeks. Dateline runs right up the middle here. Far West Pacific starts at 125 east, so right here. Again, the blue, this is 850 millibar zonal wind anomalies, so the east-west component of the wind, are the trades stronger or weaker than normal? You know, but this is up at about 4,700 feet, but a good proxy for what's going on at the ocean surface. Blues, stronger than normal trades. You just see that going the whole way down. There's the date line. But what we do see is neutral anomalies creeping their way into the West Pacific a week from now and filling, halfway to the date line sort of thing. And yeah, easterly anomalies building a little bit 4 weeks from now, but maybe there is a bit of a window right in here, according to this depiction of the model, with fingers of westerly anomalies trying to build, but you see the active phase, theoretically, like, you probably could connect these and say this is the active phase, but even at that, these are, a real active phase would have contours filling the entire area. So this suggests a very, very weak active phase of the MJO over the next 2 to 3 weeks. Now, here's where things get very interesting. This is the CFS model again. It goes out 3 months, but I don't need 3 months of data. Even a week and a half paints a very different picture. Right today, September 7th, the date line running right up the middle here. The far West Pacific starting at 125 east right here. Okay, the yellows, westerly anomalies, the blues, easterly anomalies. And this starts talking to the title of the video and talking about momentum in the atmosphere and what's going on. You see easterly anomalies, but literally 2 or 3 days from now, the easterly anomalies in the far West Pacific, almost to the date line, are to turn just dead neutral. And that pattern only gets enhanced a week from now, and after that, it's off to the races with westerly anomalies, or I'll be conservative and say neutral anomalies from, let's build a line right about there. So that's just about at the date line. And then if you want to go into Never Never Land, by October 15th, you see the easterly anomalies collapsing, moving further to the east, west anomalies taking over the entirety of they're pretty much supposed to take over the entirety of the Kelvin wave generation area a week from now, but a month from now, they're going to take over the entirety of the Pacific. This model has been hyping some sort of change like this for months now, but now, literally, we are within a couple of days of that theoretically happening, I will be watching this incredibly close over the next week to see if this materializes or if the very next run of the model it all collapses and we see easterly anomalies over here. But the model's been generally pointing at some sort of a trend like this. And if this is the case, this is not at all a La Nina pattern. If anything, it's not El Nino, but it's clearly some sort of a bifurcated split pattern with like La Nina in the East Pacific and El Nino-ish like in the West Pacific. Or maybe it's just dead neutral when you all average it together. Let's overlay the MJO here. Let's see what's going on. Well, right now, supposedly there's a weak active phase in control, but we have easterly anomalies. That makes no sense. And then you get beyond this, and there's literally no meaningful MJO signal from 3 days from now, the whole way into December, which is kind of a head scratcher, but I don't think the model really has a clue what's going on this far out. But it says a weak MJO pattern. Let's overlay the low pass filter. And this was the real key. We indicated that a couple of weeks ago. The solid contour here is the low pressure bias. You see back in May, it was the leading edge of it wasn't even in, it was just right knocking on the door to the West Pacific. But then somewhere in late July, it made a significant nudge to the east. And as of today, right about where it's been for the past month, at about 150 east, maybe even a little bit more, so halfway into the far West Pacific. And according to this model, it holds, but it's interesting that westerly anomalies continue building east of there. The high pressure bias, the La Nina signal, well, it's very weak. One contour building to two. This is weak too, building to two contours. They set up, the dividing line is 160, 165 east. So that's like half the West Pacific, holding in control for the foreseeable future. This is exactly what the model has been saying for months now. It seems like it's happening, and it's just these westerly anomalies are the key. The weakening of trade winds allows moisture to move from the surface of the ocean up high. The low pressure bias here helps feed that transport, which feeds the jet stream. And as we get deeper into fall and winter months, that would make for a stronger jet stream and stronger storm pattern. And as of right now, in the North Pacific, things seem pretty normal. And even the South Pacific, for that matter. So maybe there is some credence to all this. All right, what's going down in the deeper levels of the ocean? That's an indicator of what's going to happen over the next 2 to 3 months. We're looking at data from the TAO buoy array, but we're looking down. These are the anchor lines on the buoys. The X's are the sensors on those anchor lines. Use that in the model to connect. You see there's big areas of dead, no data. And you can build a subsurface water temperature profile. These are degrees in centigrade, so this is the 29-degree isotherm. That's quite warm water. Today, it is at the surface at 175 east, almost exactly where it was last week. The 28-degree isotherm at 172 west, again, where it was last week. And the 24-degree isotherm at 124 west, so basically south of California. I really want to see this over here pushing into Ecuador, but it's not doing this. So this sort of hints at colder than normal water here and warmer normal water here. If you're in El Nino, the warmer the normal water starts pushing off to the east because trades are suppressed. If we look at the model and we have westerly anomalies in this area, that would suggest that warm water would have a path or would have the potential to start moving to the east because trades would be less than normal and would stop sequestering the warm water in the East Pacific, or West Pacific. Let's go look at another chart here. Oh, this is the anomalies, the difference from normal for this time of year. And this really paints the picture. Warmer than normal water in the West Pacific. The entire East Pacific, well, that's like a cold water Kelvin wave. What that's really saying is easterly anomalies here are taking cold temperatures down here and drawing them up to the surface. And that is typically the hallmark of La Nina. Cold water in the east, warm water in the west, stronger than normal trades. Let's go look at one more here. This is a high-res version of the same data, but supported with satellite data, but it basically paints the same picture. Warmer than normal temperatures in the west, there's the date line right there, and cooler than normal temperatures in the east, cold water Kelvin wave pushing up, suggesting stronger than normal trades. And I think we've had stronger than normal trades for quite a while, though we looked on the charts when we were looking and we saw pretty much a neutral pattern the whole way along in here and enhanced trades over here. So, bit of a head scratcher. Here's the satellite data. This is used to measure the height of the sphere of the ocean. Take out the waves, the wind waves, the tides. Is the sphere of the ocean higher or lower than normal? Why does that matter? If you have cold water at depth, cold water tends to contract. When it does that, you'll get a little divot on the ocean surface. Warm water at depth expands. If you do that, that'll push the height of the ocean surface up a little. We're talking centimeters here. So this is the equator right here. Here's the date line. Right there, that's the Galapagos. That is New Guinea there. Ecuador right there, Central America. You got it. So, -5, -10, -15 or 20 centimeters. And really, but it's really 5 degrees north and south of the equator that only matters. And you see here, negative anomalies on the ocean surface from the date line on east, suggesting colder than normal water at depth. All over here, and then west of the date line is where all your warmer than normal subsurface water is. Upper ocean heat anomalies for the past year. West Pacific here, East Pacific here. Here was our last year's Modoki La Nina over the East Pacific, colder than normal water temperatures into about March. Trades were blowing stronger than normal here, creating upwelling, taking any warm surface water here in the East and Central Pacific, pushing it all off to the far West Pacific. We had a slackening of trades from mid-April to about sometime in early July. Warm water tried to make its way east, but here we go again. Trades build up, and you see here's the first finger of upwelling, and now you see it building just in the past week the whole way to almost the date line. The date line's over here, so a clear, some sort of La Nina pattern. I won't call it La Nina, but definitely a cool upwelling pattern has developed over the past month and a half. So then let's go look at sea surface temperature anomalies. South America, Central America, New Guinea, equator right there, date line right there. It's only 5 degrees north and south of the equator that really matters. Of course, the clear global warming signal, whatever you want to call it, the oranges and yellows, everything above normal. But here is your La Nina signal, clear as day from the Galapagos Islands the whole way out to the date line. Not particularly strong out here, but a bit of upwelling and easterly anomalies suggested right in this range. Yes, this is warmer water, but I suspect, as this is kind of a seasonal thing, it's very shallow. All it takes is a couple of gales, as we're going to get in the next couple of days, and you'll see this starting to get eroded away. A gale pushes over here. Yeah, it makes surf, but it also creates upwelling and starts mixing the surface layers, and these temperatures rapidly collapse. But this cool water here is the real deal. It's upwelling from deep in the ocean. Will not be denied. Why does that matter? Cool water doesn't support evaporation above it, and if you don't have evaporation, you end up with high pressure, clear skies building over top, and that is part of the La Nina pattern. So, the ocean, both subsurface and at the surface, is saying La Nina. It's only been that way for a month now. It takes quite a while for the atmosphere to go, oh, hey, look at this, there's cold water. Hey, I'm going to start building high pressure over here. It takes like 3 months for that to happen. All right, so let's say this has only been going on for a month. Well, we still got all of September and all of October, maybe even into mid-November before some sort of a La Nina pattern would, start to take hold in the atmosphere. Let's keep digging and just keep that in the back of your mind. Here's the sea surface temperature trend as of September 6th. A little bit of cooling, but also a little bit of warming. I mean, no big sign here screaming that it's getting any colder. Whatever cooling we have at least for the past 7 days, isn't getting any worse. Now here is an alternate sea surface temperature chart showing the deviation from normal. This basically takes temperatures across the entire planet, says here's the average temperature, and how at any one point, how does the temperatures here compare to the global average. Clear La Nina pattern here building the whole way out past the date line. Cannot be denied, but still that warming signal everywhere else. Sea surface temperature trend in the Nino 1.2 region. This is the area right there by the Galapagos and Ecuador. Temperatures you see are dropping down to 1 degree and 23 thousandths of a degree below normal. So a cooling temperature trend there, and that, yeah, to be expected. The Nino 1.2 region really is pretty noisy. The official El Nino monitoring region is the Nino 3.4 region. This is water temperatures on the equator from a point south of California out to about the date line. 5 degrees north and south of the equator. There's today's value. 736 thousandths of a degree below normal. Neutral is considered a half a degree below to half a degree above. So according to this, we weren't even in borderline La Nina conditions till August 10th. Okay, assuming that is to hold, so that'd get us to August to September, October, November 10th. That would be 3 months. At that point, the atmosphere would start definitely rearranging itself towards a La Nina configuration. But it depends how much cooler the temperatures get as to how strong that reaction in the upper atmosphere would be. Right now, this is between a half a degree and 1 degree is considered weak La Nina, and that's only if it persists for effectively 5 consecutive months. And we're only a month into that, and at that just barely. So this is no particular big deal atmospherically at the moment. And you're going to see that borne out in some other data here in a minute. This is the real teller here, the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific Ocean, Darwin roughly in the Indian Ocean maritime continent. When pressure is lower over the Pacific over Tahiti, the index goes negative. Well, we're positive today, 6.95, which is not a big deal. Let's just sort of look back here. Well, I'm just looking to see what's the balance of the values been. They've been positive. Okay, so we can look at a 30-day average. 5.02 is the current value. Where were we a month ago? 5.57. So this typically is influenced pretty well by the MJO. Active phase of the MJO drops pressure in Tahiti. The index goes lower, and you can see that right in this region here. So this suggests we were in active phase. Now we're moving to the inactive phase. 90-day average is your La Nina El Nino indicator. 90 days, notice that's 3 months, and that's why I said it takes like 3 months from what happens at the surface to actually manifest itself up in the atmosphere. Value today, 3.6. If you were looking at La Nina, this needs to be up at 10 or 11 or 12 or something like that. Where were we a month ago? 3.76. So basically, we've gone nowhere in a month, sitting at, I'd call it ENSO neutral, biased just slightly towards La Nina. Let's go look at a graph. All right, here's the 30-day running average of the Southern Oscillation Index. Here's La Nina above +7, according to the Bureau of Meteorology, and El Nino is down here below -7. Here's today's value, +3.2, according to this. This is maybe 2 days old sort of thing. We've been hovering in ENSO neutral since May, I'd say, right there. Here was last winter's Modoki La Nina, pretty in Nowheresville. Here was our last El Nino. Where was it? Somewhere in here in 24, or even down in 23, really. Okay. The downward pushes, active phase of the MJO. Upward pushes, inactive phase of the MJO. So here was inactive. Here was our active phase, the end of July. We just went through an inactive phase, and then down into a weak active phase, and now we're heading back up. You see, the MJO and these active and inactive phases are really going nowhere, a variation of like 0 to 6. no big deal, as pretty much as neutral as you can get. And one final bit of data, outgoing long wave radiation. This is not a forecast or a projection. This is what's actually been happening for the past year. The date line's right here. Okay, far west Pacific starts at 125 east, so right there. And what we see, so the oranges and the reds, clear skies, high pressure, La Nina basically. And here was last winter's La Nina, which for the most part was displaced late into February, March, and April, and then it faded. Notice more cloudiness right on the hairy edge of entrance into the West Pacific, and that's been persisting since February. Now here we are, a building signal with the leading edge of that halfway across the Pacific, still this persistent dry air pattern right over the date line. Sort of smells like what it was a year ago, but notice a year ago there was no cloud cover in the far west Pacific, where this year there is considerably more. I take this as a sign that there are westerly anomalies already building in the West Pacific, and sort of confirming what the 3-month CFS model suggests of this building weak, I'll call it neutral to slightly westerly wind pattern building over the West Pacific. And to me, that suggests, well, let's go take a look at some things here before I say anything. The final bit of data, the forecast, sea surface temperature forecast in the official El Nino monitoring region, the Nino 3.4 region, from the CFS version 2 model. All right, so half a degree below normal to half a degree above is considered dead neutral. According to this, in September, we're at half a degree below normal, but still officially neutral, then falling. Now, this is the more exaggerated version of the CFS model, with temperatures going to, I'll call minus 0.85 of a degree in mid-October, mid-November, into about mid-December, and then quickly retreating back to normal. So this suggests let's see, this is September. So 1, 2, 3, 4-month dip into, at best, weak La Nina territory, and then returning to normal after that. But this is a bit over-exaggerated. The PDF-corrected version probably shows it even better. It shows temperatures only going to 3/4 of a degree below normal, so 1/4 of a degree into La Nina for 1, 2, 3, 4 months at best. 3.5 months maybe. That's not a La Nina. That's not even a Modoki La Nina. That's just a generally biased cool trend in the fall. And in December, right as your winter starts December 21st, by December 21st, you're already reworking your way into neutral territory. So this suggests a pretty, I'll call it favorable, if you believe this model. All the other models say that even this is probably overstated. We looked at the consensus model, I think it was 2 weeks ago, and they were only saying like 0.4 of a degree below normal, which is basically normal. So for right now, we're looking at potential swell from the south and from the north. Hawaii is getting the first bit of swell and doing better than what the models forecast. Hopefully California will get a taste of that too, maybe Tuesday, Wednesday, Thursday sort of thing. But if not, North Pacific swell is forecast. Nothing huge. We're talking 3 or 4 foot, something like that. Chest high, shoulder high sort of thing. Mainly north of Point Conception. I don't think Southern California is going to see any of it, just because the swell's from too north a direction. But then there is the hint of more behind that, and there is still the hint of Southern Hemi swell at the same time. So we're in the shoulder season, in between. North Pacific trying to come online, South Pacific not giving up the ghost yet. Best of both worlds, depending on where your favorite breaks are and what swell directions work best there. Looking longer term, though, I think we have this situation where we have a La Nina that looks like it's trying to develop, but all available data says it isn't going to do much. And if westerly anomalies actually start building over the West Pacific in literally the next 3 to 4 days, then I would say we're going to be in a reasonable pattern. At best, it'll be like the weakest of weak Modoki La Ninas this winter. And maybe with the west anomalies over the West Pacific, that'll feed the jet stream, and we'll actually do okay. I mean, we're coming online way earlier than I thought we would. I mean, it's nothing major. I want to see some solid 30 to 35 foot seas in the Gulf of Alaska, but we're moving in the right direction. So I consider that favorable. And then as we get deep into winter, like around Christmas time, La Nina's supposed to be gone. We could be off to the races. Now, as somebody commented in the videos, just earlier, an hour or two ago before I made the video, well, maybe, just maybe there'll be rain into Southern California. I don't know if I'm going to go that far. You know, I think if we get surf, we should be happy for that. I am not expecting above average rainfall in Northern California, much less Southern California this winter. But maybe, you know, weirder things have happened. So I don't know. If you got thoughts on that, write it up in the comments. I would like to hear other perspectives. Me talking to myself doesn't always, that's not a great way to flush out ideas. So the interplay between all of us is always welcome and a good thing. All right, that's the video for this week. Just a heads up, there will be no video next week. I got things going on. I won't be able to do it. But after that, we'll be back to a very regular pattern. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. Comments, questions, always welcome, like we talked about. And if you'd like to make a small contribution to help the cause, you may hit the super thanks button down below, the heart with a $sign in it. With that, we are done for this week. We will see you again in 2 weeks. Enjoy your time off from the videos. Go get some surf, have some fun. This is the magic season. Winds are down in California and Hawaii, and cleaner conditions, warmer waters, and hopefully some fun surf over the next 2 weeks. See you in 2 weeks. Goodbye.